Decomposition reactions. Woo! That's what I'm talking about. Whoa, sorry, I didn't see you there. We're going to talk about some decomposition reactions right now. Now, I don't know if you know, this is kind of a gross question, but I don't know if you know what the definition of decomposition means, but decomposition is breaking up. So something complicated breaking up into simpler things. This is going to sound gross, but when living things decompose, they turn into the nutrients that they are made up of. That kind of thing. That's okay. All right, whatever. That's okay. So the definition of a decomposition reaction, though, is a compound turning into two or more elements. So decomposition reactions always involve one compound breaking apart to form two or more elements. When predicting a chemical reaction, it is often useful to write out the word equation. We did this yesterday. Do you remember doing this yesterday? I do. I remember doing this yesterday for formation reactions, though. Decomposition reactions are the exact opposite of formation reactions. Okay, whatever, that's okay. So the idea, we're going to be starting with a compound, and we're going to be turning into two or more elements. So example number one, the decomposition of aluminium sulfide. So that means we're going to start with aluminium sulfide. Okay, no problem. Aluminium sulfide. And we're going to turn into whatever the elements are in aluminium sulfide. Hopefully, it's not too much of a strain for us to recognize that aluminium or aluminum is one of those elements, and the other one is definitely not sulfide. The other element is definitely not sulfide. It is sulfur. Okay, all right, let's try this. So let's take that word equation and let's turn it into a chemical equation. Every time we do this, right, we're just going from names to formulas. That's all we're doing. So we're going from names to formulas. What kind of a substance is this? This is an ionic compound. And because it's an ionic compound, we should be able to write out the ion charges. Aluminium is 3+, sulfide is 2-. So we're going to need 2 aluminiums, and we're going to need 3 sulfurs. And it's solid because it's an ionic compound at room temperature. Perfect. So this is going to break up into aluminum and sulfur. Well, what's the formula for aluminum? The formula for aluminum is Al solid, because it is a solid at room temperature. And we're going to make sulfur. Now, are either of these in Hofbrinkel? What do you think? No, they're not in Hofbrinkel, but what's Hofbrinkel's chant, right? Chant, not chat. What's his chant? I'm waiting for you to chant it for me. P4S8, who do we appreciate? Hofbrinkel, no, whatever, that's fine, okay. So sulfur's formula is S8, P4S8, who do we appreciate? So now that we've got our skeleton equation, aluminium sulfide turns into aluminum and sulfur. Now we can balance this reaction. Which of these elements is more complicated, aluminum or sulfur? Well, I know which one it is. It sure looks like it's sulfur. So what's the lowest common multiple between 8 and 3? Well, I believe that's 24. So we're going to need 8 of these, 3 of these, and 8 times 2 is 16 aluminums. There we go. So the first reaction is done. We took that substance, we recognized that it's a decomposition reaction, so it's going to break up into its elements, whatever its elements are. So aluminium sulfide is going to turn into aluminium and sulfur. And then we wrote down the chemical reaction, or the chemical formulas for those, and balanced the reaction. Let's try another one. When water is reacted with electricity, it is broken into its elements. Okay, no problem. Let's write a word reaction or word equation for this. So we're going to start with water. And it's going to break up into its elements. Well, what are the two elements that make up water? I'm waiting. Yeah, you're right. It's hydrogen and oxygen. So we're going to break this up into hydrogen and oxygen. So water, well, let's turn all of these into formulas. What's the formula for water? H2O, liquid. And what's the formula for hydrogen? Well, hydrogen is part of Hofbrinkel. Hofbrinkel, so H2 gas. It's a gas at room temperature. You just got to check your periodic table. And then oxygen, Hofbrinkel, is O2 gas. So now all we have to do is balance this reaction. Let's do this. H's are more complicated than O's, but we got two of them and two of them, so we're fine. One O and two O's, so we need two of those. Now we've got 4 hydrogens, so we need 4 here, so we'll put a 2 here. Boom. Woo! That's what I'm talking about. Pretty straightforward. If you have any questions, let me know. There's a Google Doc, and there's the office hours from 10:45 to 11:15. So, yeah, let's do another one. So let's look at the decomposition of aluminium chloride. Well, we got to start with a word equation. So we're going to start with aluminium chloride. And this is going to break up into its two elements, which hopefully is not surprising. Aluminium and chlorine. We're running out of room. Got it. There we go. So now we just have to turn these names into formulas. We just have to turn them into whatever the formulas of the substances are. Aluminium chloride, what kind of substance is that? Well, that substance is an ionic compound, so let's write down the ion charges. 3 plus and 1 minus. So we need 1 aluminium and we need 3 chlorides. And because it's ionic at room temperature, it's going to be a solid. Okay, all right. So this is going to turn into aluminium and chlorine. Well, what are the formulas of those things? Aluminum is an element, and it's not part of Hofbrinkel or P4S8, so we just say Al solid. Boom. Nice. Chlorine, is it part of Hofbrinkel? Yes, it is. It's part of Hofbrinkel. So Cl2, and it's a gas. You just have to check your periodic table. That's all you have to do. So let's go ahead and balance this. What's more complicated, aluminums or chlorines? Chlorines are definitely more complicated. So we got 3 on this side, 2 on that side. So I'll put a 2 and a 3, and then 2 aluminums now. So I'll put 2 aluminums. Done. Swish. Again, if you have any questions, let us know. On the next page, there's a bunch of balancing reactions practice. So go ahead and perform those balancing reactions. There's lots of them here, and I'm not going to go through any of them because we've gone through enough in the past few days that you should be confident. But please, 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 please let me know if you're not confident. I can work through a bunch of examples with you if you want. On the next page, What we're doing is we're predicting the products and then we're balancing the reactions. So we'll do a couple together, but for the most part, you should be pretty confident, or you should be pretty capable of doing this. Nitrogen trifluoride, well, what's it going to break up into? The only thing it can do is break up into nitrogen, N2 gas, and fluorine, Hofsprinkle, fluorine gas. Perfect. So now we just have to balance this reaction. 2 nitrogens, 3 fluorines times 2 groups of 3, so 6 fluorines. How do I make 6 over here? Well, you put 3 there. Boom, done. Just please recognize that the coefficient in front of the nitrogen, is a 1. We don't write it, but it is a 1. Okay, let's try the next one. Nickel 2 oxide is decomposing, so it's going to turn into nickel and oxygen. Again, nickel's a solid because it's a metal, and metals are always solid at room temperature. You can just check your periodic table if you want to. And then oxygen is a gas. You hopefully should know that, but again, you can just check your periodic table if you want to. That's no problem. If you don't believe me that nickel's a solid here, okay, let's try it out. Let's look at it. So nickel is right here, element number 28. And when we go and look at what it should be, whoa, just give it a second. Here we go. It's got a white background, so it's a solid at room temperature. Again, we'll look at the chlorine. Chlorine is shaded in gray, so it's got a gray background. And when we look at it, gray things are gases at room temperature. Perfect, no problem. So let's get back at it. And so we got to balance this thing. Okay, 1 nickel, no problem. 1 oxygen, 2 oxygens. Uh-oh. 2 of those and 2 of those. And that's how we're going to balance it. So we got 2 oxygens, 2 nickels, 2 nickels. No problem. You should be able to do the rest of these, okay? Watch out, please, watch out for Hofsprinkle and P4S8, please. So if you're ever making any of these elements all by themselves, right? If you're making hydrogen as an element, or oxygen, or fluorine, or bromine, or iodine, or nitrogen, or chlorine, or phosphorus, or sulfur, any of those that they are polyatomic elements. No problem. And then the very last section, this is the hardest. This is a very typical exam style question, and you're going to be expected to know this moving on to chemistry 20. So you're going to be expected to know that, when nickel 3 chloride decomposes, it turns into nickel. Sorry, I think I said it was supposed to be oxygen. Oxygen's a gas. Whoops, never mind. Anyways, when nickel 3 chloride decomposes into its elements, you need to know, okay, 3 plus and 1 minus. So nickel 3 chloride, that should be automatic. For you to turn nickel 3 chloride into NiCl3, that should be like, we've done that a lot over the last little while. Again, if you need help, please don't be embarrassed. I'm here to help you. I'm on your team. My goal, my job is to help you succeed. That's all I'm here for. That's all I want to do. Okay, anyways, enough of me being on my pedestal. So nickel chloride is going to turn into, well, nickel and chlorine. So it's going to turn into nickel solid and chlorine Hofsprinkle gas. And then you can balance it. 3 chlorines, 2 chlorines. So I need 3 of these and 2 of these. And 2 of those. Perfect. That's what you're going to be doing. We're going to do one last example, and then I'm going to get you to finish all of the examples in our notes, okay? And it's just a couple pages of work. It's not that big of a deal. So antimony 5 oxide decomposes into its elements. Holy guacamole, antimony? What is antimony? I don't know if I've ever heard of that before. Let's go looking for antimony. No. Yes, here we go. Antimony is right here, element number 51, and it's saying antimony V. What's the charge on antimony V? I should hear all of you say 5 plus. Okay, so antimony V means antimony 5 plus. Perfect. So this is 5 plus. Oxide, you can look at it in your periodic table. It's 2 minus. All right, no problem. So oxide's 2 minus. So we need 2 antimonies and 5 oxides. So Sb2O5, and it's an ionic compound at room temperature, so it's a solid. Perfect. This is going to decompose into its elements. It's going to decompose, unsurprisingly, into antimony and oxygen. So antimony and oxygen. Perfect. Now we just gotta balance it. That's all. That's old news, baby. Okay, 5 oxygens, 2 oxygens. What's the lowest common multiple between 5 and 2? What's the smallest number they share? 5, 10. Yeah, 2, 4, 6, 8, 10. Sure. So we want to make 10. So 2 of those and 5 of those. And then there's 4. 2 times 4. 2 is 4. So 4 antimonies. So that's all I'm going to do with you. Okay. I would like you to finish the rest of the notes. So finish the rest of these examples. Just a couple examples there. Finish the rest of these. Predict what it is and balance the chemical reaction. And then do some balancing. So the key for these notes will be on the instructions for the day. Let me know if you have any questions, and good luck. Have fun.